Well, hello, everybody. Welcome to Extreme Flight School. This is a discussion about extreme fabric technology. My name is Andrew Allen. I'm sales engineer here with Extreme. I am in Toronto. What I have with me is Scott Schwal in Montreal and Greg Patzer in Calgary. Greg and Scott will be monitoring chat and will keep me honest with the discussion. Your microphones are muted during session. Please, if you have any questions, please use Q&A panel, and Scott and Greg will reply to any questions, or if needed, I can stop and go back to slides and talk about it, and we also have Q&As at the end as well. Okay. Agenda. So first of all, this is introductory session about Fabric. This is not meant to be in-depth technology discussion about configuration. There is no certification at the end, nothing like that. We will talk about history of Extreme Fabric, how it works, and more importantly, where and how to use it. For those who are new to Fabric, who never heard about it, it will be a good introductory session. See again how it may apply to you or may not apply to you. And for those who have Fabric deployed and in place already, this could provide, it could be a refresher, so to speak, and provide you maybe some additional ideas how and where to use it. So you know, Extreme Fabric, I will refer it to by different names sometimes. Fabric and I will say SPBM, shortest path bridging, it is the same, or you know, it can go back to previous names. It used to be called Avaya VIN infrastructure, Avaya VIN, Virtual Enterprise Network Infrastructure, or SDNFX. For those people who may remember those names, it's all the same. All right, let's talk about history, where Extreme Fabric came from. If you look at the list of, so here is the list of all the acquisitions that Nortel has done in the past 10 years. The Fabric technology was acquired in 2017 by Extreme from Avaya. So 2017, Extreme acquired Avaya data technology, and the main reason for that acquisition was the Fabric. Right, and before that, Avaya acquired it from those assets from Nortel. And again, the main reason for acquisition of data assets from Nortel by Avaya was Fabric as well. So Fabric is, you can say that those are roots of the Fabric coming from Wellfleet, Synoptics Bay, and Nortel Avaya days. So talking about the history of Fabric, we need to talk about a little bit about history of Ethernet. And the reason for that is that this Fabric is the Ethernet Fabric. In fact, it is official Ethernet. It's a in a IEEE standard. It's IEEE standard technology. So we cannot talk about this Fabric, and it's not separate. It cannot be separated from Ethernet itself. So let's take a look at at the history of Ethernet. So it's very old technology, as you know. It started in 70s, and during that time in 70s, 80s, 90s, we had lots of other network technologies. For those who remember, we had something like Talking Ring, we had ArcNet, FDDI, even ATM lately. And you can argue that any of those technologies was better than Ethernet. All of them or any of them would be faster, they would be more reliable, they would be more robust. So why is there no Ethernet finally had won this war? And the main reason was the price. Ethernet was cheap. And by the virtue of it, like where we are right now, since about about 2000, probably 5, we have nothing else other than Ethernet. All right. So original Ethernet was, again, built to be cheap. And as a result, it was built as a bus, right? It didn't provide any scalability. It was, if you look at it, it was the best you can do, maybe was 25, 30 users per segment. It didn't provide any virtualization. It didn't provide any redundancy whatsoever, right? And or any other, protocols. But if you look at the requirements for any network we have today, they are completely different. The reason for that, because networks these days are not being used for, it's not kind of luxury anymore, right? Everybody, any business needs network to run a business. So you can, in a regular converged network of any size, you can have it's used for data, it's used for voice communications, for video surveillance. It can be used for applications like the card readers or even lightning technology. So we do need reliable networks. Every time we have a problem with reliability, network goes down, and especially the major organizations, we hear about it. Everybody remember Rogers outage or a recent, for example, security breach at SeaKids. So networks, the requirements for modern networks, they have to be reliable, they have to be always on, they have to be secure, right? They have to be flexible, they have to be scalable. You cannot deal with one subnet anymore, right? So we need, they have to, networks these days comprise from anywhere from a single device to tens of thousands of devices. And for protocol support, it's not only Ethernet, it's not only just data communications we're talking about. There is requirements to have IP routing, multicast, and so on and so forth. Now, how industry was dealing with the lack of those technologies, I guess, on Ethernet network itself. So what IEEE or other organizations like ISO or IETF have done over time, every time it was something that needs to be improved, we created a protocol. So since the Ethernet was ratified in '83, we added shortest path bridging, for example, for loop prevention, or we added BGP for BGP routing. We added QTAC, VLANs in 1998, IP multicast, and so on and so forth. So you can, this is just a few of those protocols, but as you know, there is I can only guess hundreds of protocols you can enable on Ethernet network. So at the end, yes, we have made Ethernet scalable, reliable, maybe more reliable, the more universal because it could support multiple protocols and standards. But have we made it simple? No, we made it more complicated, and that complexity is the main reason that networks are not maybe deployed the way how normally we would like to deploy it. So because of all this, when networks are designed, you have to keep in mind everything, topology, how it's all connected. You cannot just plug and play and kind of design network the way you would like to design based on your topology. You have to, your network design, your network topology, it's all always hand in hand, and you have to keep in mind how would you use that network. So how story goes, okay. Guys at the IEEE were fed up with all this. They said, enough is enough. So, we had this Ethernet technology over that time was probably 40 years, or maybe 30 years. We have to come up with something new. So they decided to build what they call it Ethernet 2.0. And Nortel, back in, it was about 2005, 2006, Nortel was already working on the technology. And they proposed this to IEEE. So IEEE in about 2006, they came up with a task force, a task group, 82.1 AQ. And by 2012, they created a standard called the shortest path bridging, and it was ratified officially. So IEEE call it, and the main reason, funny enough, for all this, it was a problem between IEEE and shortest path bridging. They said it's not, and for those who ever tried design shortest path bridging network, you know that it will never work, right? It will work for a few switches, but you cannot build a network based on that one. So shortest path bridging was ratified in 2012. It is the only technology that is ratified or standardized jointly by IEEE and IETF. As you know, IEEE works or deals with layer 2 communications, and IETF, or Internet Engineering Task Force, deals with layer 3 routing and above technology. So what we get, and in 2014, that task group, 82.1 AQ, was folded into the bigger 82.1 AQ standard. So without doubts, Ethernet is, so the shortest path bridging is Ethernet standard. It is written in the books, and you cannot separate shortest path bridging or fabric from Ethernet. It is exactly the same thing. So now we have our traditional Ethernet, and now we have this brand new Ethernet 2.0, if you like. Make sense so far? All right. So if you look at just kind of evolution of this Ethernet, again, for a number of 2 or 3 decades, nothing was happening to it until about 98. You probably remember IEEE introduced Q tagging, how we call it these days, Q tagging. What allowed us to do, instead of 1 segment, now we can have 4,000 segments. So now they made Ethernet scalable. In 2005, the standard called Q&Q was introduced. It was introduced mostly for carriers. So that would allow carriers to provide LAN-E or transparent services on top of Ethernet infrastructure. So, you can have 4,000 queues and 4,000 services in each. So 4,096 times 4,096. In 28, Nortel again proposed that it was ratified standard called backbone PBB, provider backbone bridging for MAC and MAC encapsulation. That would be, the standard was related for bridging of separate Q&Q networks together. If you look at the provision, so and that standard used something called service identifier, 16 million. So instead of 4,000 times 4,000, you can service identifier was 4 bytes, so it would allow for 16 million it's a services. If you look at the provisioning column here, all those standards, you still would need to do configuration changes. Everywhere you touch, you would need to do configuration changes on the edge of the network and in the core of the network, in any case. So shortest path bridging, or how we call it SPBM, right? Let me just, okay. Interestingly enough, IEEE didn't want anything new here. What they have done, they have reused 3 protocols, put them together, and came up with shortest path bridging protocol. And those three protocols are they use SIS protocol, and it's not that widely used protocol. It's not. I mean, it's some devices would support it back in days. It's an ISO protocol. It's a routable protocol. It's a link state protocol, and it is, if you know OSPF is based on SIS protocol. And SIS protocol does not use any IP routing. It can route. Actually, it's not just for IP routing. It can route anything. So what they have done, they combine SIS protocol. They combined 8.1H provider PBB or MAC and MAC encapsulation, and they added connectivity fault management, which is a standard-based management again, which can be used to kind of provide some diagnostics between devices. So IEEE didn't invent a wheel here. Instead, they reuse what they had, and they come up with one beautiful protocol, shortest path bridging. And so here is a biggest difference, kind of glaring difference between traditional networks or original Ethernet and the Ethernet 2.0 or shortest path bridging. So traditional Ethernet stack would have this hierarchical dependencies. You would have a physical infrastructure, and then on top of that, let's say if you want to add virtualization services, like, and the only one was available was VLANs or QTAGs, you would need to enable that. If you wanted loop-free topology, you would enable spanning tree protocol. If you needed, on top of that, to add IP routing, you would need to enable some dynamic routing protocol, RIP, OSPF, BGP, something else. If you wanted, on top of that, enable multicast routing protocol, there was like something like DVM-RP or PIM. And if you want to provide even more virtualization, on top of that, you would need to enable MPLS, for example, and there's a whole MPLS stack there. And because of this, how it's all designed, right? The Ethernet. So each upper protocol is dependent on the low level protocol. If, for example, something happens to OSPF routing, your multicast will not work, right? Or if something happens to the spanning tree, when it decided to reconverge for whatever reason, all the upper protocols would go down, and everybody will have to wait until the underlying infrastructure converges or underlying protocol is up before building the next structure. Not only it is prone to all sorts of errors, the recovery time or reconvergence time or even time to service is all affected. SPBM, on the other hand, combines all this, the whole protocol stack or all the services that you see on the left are supported by infrastructure itself. So all this layer 2, layer 3 multicast and virtualization services are supported inherently by the SPBM. That means they're part of infrastructure. Right? That means there is no top-down dependency between the protocols. They're all running independently of each other. And as a result, if you look at how much you need to configure on the left versus how much you need to configure on the right, instead of configuring maybe a dozen of different protocols, there is only one protocol in SPBM to configure, ISIS protocol. And we have all the services are supported by infrastructure itself. That's a massive difference. All right. So let's get to kind of understanding of shortest path bridging or fabric. So Ethernet never had a control plane, or it was, you can argue that control plane and data plane, it was the same. Like OSPF is not really running on a separate infrastructure. It's running, for example, using the same routing table, right? It is not a separate thing on Ethernet protocol, on Ethernet infrastructure. So shortest path bridging has a clear separation between control plane, data plane, and performance monitoring tools. For control plane, shortest path bridging uses ISIS protocol, which is a link state database, which is used to build the network. Right, the ISIS protocol is running between all nodes on the network, and they build topology, and each device, if you look at the topology table, I'm not talking about IP topology table, I'm talking about network topology table, you can see the whole infrastructure. Data plane is that is MAC and MAC encapsulation or PBB from carrier world. So data plane, if you look at traffic between nodes on shortest path bridging network, you will not see your regular VLANs and your regular user MAC addresses, regular user communication. No, you will see 2 or 4 MAC addresses of those nodes, backbone nodes between them, and all the traffic will be tunneled inside MAC and MAC packet between the nodes. Now, the user traffic, on the other hand, is mapped to a service identifier, and there is a 16 million service identifiers to choose from. Short path bridging does support load sharing. It does support loop prevention. It does support multicast. It does support QoS and all sorts of QoS traffic, and it does include integrated OEM management. So that is used. That's what we have is this that we never had before with regular Ethernet. You can do something like layer 2 trace route or layer 2 ping, for example. Right, you can actually see how traffic goes between different switches on the network. If you do it on a regular Ethernet network, first of all, you cannot see anything at layer 2. you can do ping or trace route, for example, at layer 3 only, right? You cannot, but if you have a layer 2 switch in the middle, that won't show in your ping, right? You know that, right? So it's only, so in this case, what we are talking about, it's the actual layer 2 or the infrastructure itself OEM tool. So we can see how traffic goes from switch to switch to switch, and what is the preferred path, and how it's all done. And we can predictively see how unicast and multicast traffic, how it goes to, and where it's supposed to how to get from point A to point B. All right. Operations now. So if you need to build a network, doesn't matter what you're building. Let's say a campus, small campus network. If you have, your layout here would be, for example, couple of core switches, maybe data centers, maybe some closets somewhere, right? And you have physical links. Well, first of all, if you were to use traditional Ethernet, and if I ask you to build something like that, you'll probably say, what are you thinking? That's impossible. You have so many loops here, right? So, let's say, sorry. So the traditional Ethernet, you can probably build this one, right? But you'll have to figure out how to deal with the loops. If you want to use layer 2 communication between the nodes, yes, so you can probably tag VLANs here and there. But then again, what about redundancy? You cannot just design network this way, and nobody would do it, right? Shortest path bridging is completely, or fabric is completely different. Each node runs an instance of ISIS protocol. When you connect them together, and topology doesn't really matter. And this example is maybe not, like I said, not the best example, not the way how would you normally do your network. But if you look at the bigger schema, right? If you have a data center, wiring closets, and something else, that quite well could be a physical network layout, right? So when you connect network devices or fabric switches together, using ISIS protocol, they will establish adjacencies, and each node will calculate the whole network. They will run what's called Dijkstra algorithm. And if you look at the routing, not the routing table, topology table for this node, it will, you will know how to get, for example, to this node here. The whole network will calculate itself based on the cost of the links. It will, from this node, for example, we will know that there is 2 ways to this node, and they both equal paths, for example. So that's again, that's what you don't have in your normal network. Your normal networks, you can say dummy switches. They don't have anything running. There is no protocol or technology that allow them to talk to each other and establish a network connectivity, kind of, from the point of view network topology. Your regular network would never know how it's all connected together. I mean, yeah, you can say OSPF can do that, or some maybe BGP at layer 3, but I'm talking about layer 2 here. I'm talking about the actual infrastructure here. So step number 1, we connect network devices together, and they do build a network. And I'm not talking about user traffic here yet, it's just the network infrastructure itself. So what we can have here is, so first of all these red links, or all the ports on this diagram, we call them NNI ports. That's a long forgotten word for network to network interface, and they truly are network to network interface. That means you don't configure user traffic on them. They are intended for network to network communications. They are plug and play. So in a SPBM or fabric network, ports that you designate for NNIs, they are configured, all of them, in identical way. You can take any port, you can take any NNI port and connect it to anywhere you like, to another NNI port, and shortest path bridging or ISIS will will establish adjacency, and it will recalculate the new path. If you disconnect it, it will recalculate the new path again. Okay. Now, the shortest path bridging network does not require any IP to be configured on the network. I mean, this is something, again, that you can have a fully routed network without single IP address on it. Yeah, sure, you need IP addresses for switch network management, but IPs are not required for operations of fabric networks. They are not. I mean, there is not even place to put them in for ISIS. And from why we call it fabric? Because the whole network, like if you look at this network, you can argue it becomes a single entity, single switch. So from point of view of how would you look at this network, once you have this all connected, you don't have to touch or configure any of the uplinks ever again. The same way if you have, for example, a chassis, right, or a stack of switches, you configure services from port to port. You enable VLAN, but you don't configure backplane, right? You never need to program an ASIC or backplane for a stack, right? You just configure it at the edge of a stack, and that's about it. So fabric or fabric network is exactly the same. You don't need to touch or reconfigure any of the uplinks, or in fact, any of the core. If you don't need any services, any user services on the core networks, you don't have to touch them ever again. And that's it. Now let's see how user. So that was fabric itself. That was network part of the fabric. Let's take a look at user traffic. How user traffic, how it is being configured on the fabric network. Let's say you need to configure communications for VLAN from this point to this point. If it was a traditional network, what you need to do? Well, you would need to configure that VLAN on this port, that port, on this switch, on this switches, figure out how to do with the loop here. And, can you do it this way too? Yes, but that becomes really, really complicated, right? So, traditional network, in traditional network environment, you would not only configure user ports or user on the left here, user connectivity, but you also have to configure the rest of the network all the way to this one. In a fabric network, you don't need to do any of it. So the network, the fabric does it for you. All you need to do, and that's the only command, is only one line of code or only one click is required. Once you create your user VLAN and the port, user VLAN and the port, with one single command, you assign that VLAN to a virtual service identifier. And that's about it. You don't need to touch anything. You don't have to configure anything on this uplink or on these core boxes, nowhere else. And not only traffic will follow shortest path, but at the same time, the way how it works, the ISIS protocol will advertise that, hey, I do have virtual service ID 100. Everybody else, whoever on the network needs to connect to the same service, that's what it's already there, right? So this switch will advertise service ID. So once the switch needs that connectivity, it will just connect to that service identifier, and that's it. There is nothing else on the network. And if you break this link, for example, it will follow the next shortest path. Even if you break, let's say these two nodes, it will automatically follow this path, whichever is the shortest path, next shortest path. Now, what is amazing, again, the recovery time. Let's say if traffic goes this way because shortest path, if you break a link or reboot a switch, let's say this one, the recovery time, well, we advertise it sub-second. In reality, it's anywhere between 10 milliseconds to around maybe 250 milliseconds. So if you have, especially when you have those critical services running on the network, right, 10 milliseconds or even 100 milliseconds is really, really good, right? given the fact that the whole network is a layer 2 network, and there is no so another important piece to understand here, there is no blocked passes. There is no blocked links here. The whole network, each and every single port is active. And depending on traffic going from one location to another, it will be taking one pass or another, or it will also provide load balancing depending on service ID number. So if you have equal cost path, right, it will take one or another. So we have full protection, sub-second, I would say instantaneous, almost instantaneous recovery. Now, okay, where I am. Oh, okay. Routing, IP routing. On a normal network, you can enable, not only you can have layer 2 VLANs, you can also enable IP routing, right? Absolutely. So we can do exactly the same on Fabric network. If you have VLANs, if you need routing for those VLANs, just assign IP address, right? And it will route. And you can have, I have a second picture here. Then, because we already have one very good routing protocol called ISIS, Fabric uses the same routing protocol for IP routing as well. So I can have my layer 2 redundant network. On top of that, I can enable routing on that, and I can have fully routed network. Then I'm talking about dynamic routing protocol, very fast dynamic routing protocol, all part of infrastructure. I don't have to configure anything new. I can create. So on top of that, not only I can enable routing at the edge of the network, for example, if I want to, I can take kind of peel off that IC. Let's say those are my edge switches, right? I can peel off that IC from my core switch and enable routing there with VRRP, right? There is no limit, or there is no place I need to route. I can route for any service. I can route anywhere on the Fabric network. And all this routing is provided with the same sub-second recovery as the layer 2 services. And again, it's all edge-only provisioning. I don't have to configure. I don't have to touch anything in the middle. I never have to touch. In fact, if I don't want to, I have core routers. There is absolutely no reason to touch ever. They're only doing switching at this point. We have customers that was actually interesting coming to our Fabric trainings, and they do have Fabric. When we ask them, why you guys, you already have Fabric, why do you want to learn Fabric again? They say, well, we configured our Fabric 5-6 years ago. We never had to touch it again. We forgot even how it's configured. That's why we're here for a refresher. Okay, so that was layer 2 operations and the routing. Layer virtualization. So let's say you have on two parts of the network, you have VRFs. For those who don't know what VRF is, VRF stands for Virtual Routing Forwarding. VRF is a virtual instance on a switch. It can take, let's say, separate number of VLANs and ports into a VRF, and that will be a routing instance on that router, totally separate from other VRFs. So people use it for security, people use it for traffic separation. Reason it's not being used that often because it's complicated. You cannot, if you have multiple switches on the network, it's almost impossible to extend those VRFs across the network because you would need to configure VLANs all the way. So in this network, again, for each VRF, and I've seen network with like a dozen of VRFs, you would need a normal network come up with a VLAN, extend it over, and enable separate routing instance, taxing the hardware. So with the Fabric operations, we call something called layer 3 VSNs. And again, I'm not oversimplifying it. It is as easy as that. If you have VRFs, and if you want, and in this case, I have one VRF, I have two networks and two other networks here. To join them together, I can do it with one single command. And so that's what it is. VRF assign it to IC number, IC 200 in this case, and the fabric will automatically join them together. All part of the fabric. And I can have a dozen, we support up to 512, I believe, VRFs on the network if needed. VRFs and nothing else to configure. Even this one is edge-only provisioning. I don't have to touch the core network ever again. And yeah, so this service like this one, so you know, is available in very close to MPLS IPVPN service, but it's all run on your regular pizza boxes on your network, right? And I will touch upon which devices do support Fabric, right? But you can build this IPVPN or MPLS type service with a few commands on your network and with a single protocol, all protected with the same shortest path bridging, with the same exactly redundancy. All right, multicast. Okay, so let's say you need a multicast network, and multicast, although it's amazing service, people don't use it that often for a few reasons. It's a complex, right? It may kill your network. It usually does if you run multicast between multiple VLANs. It does require some multicast routing protocols, and those are very difficult to configure. So so first of all, what multicast is used for? Multicast is used for things like video surveillance, most common one. For let's say the in IP telephony or in for broadcasting, it can be used for zone PA system, zone PA system. It can be used for some imaging of devices. You know, there is a number of multicast applications out there, but it's not being. Majority of our customers, they said, okay, we are not doing multicast. It's too complicated. You have to the most common protocol called PIM or sparse mode, or PIM stands for Protocol Independent Multicast, sparse mode. You would need to configure a whole bunch of device things like rendezvous routers, or rendezvous routers and bootstrap routers, and PIM is so slow to reconverge. If you have traffic going, if you break a link, it can take up to 2 to 3 minutes for PIM to reconverge if it does reconverge. Sometimes, quite often, it doesn't. And because how it works, PIM will always hit CPU, right? So CPU load goes through the roof, and quite often, if something happens on the PIM network, it will cause a meltdown for the core switches, and the whole network will go down. That's the main reason why people don't usually use PIM. Well, let's say in this network, I have one sender, let's say a video surveillance server, and I have number of receivers, and they want to join a multicast group, right? 23.9, whatever it is, it could be a video stream, right? Multicast does provide automated zero-touch configuration service for multicast. All we need to do is to enable it on a VLAN. What's going to happen? Fabric itself, it will intercept those communications from sender and receiver, and it will automatically join them together with automated ISIT, right? In this, I mean, it's automated, but you can also in the latest release you can make it. You can predefine it as well. Nothing else to do. It is as simple as it gets. And on top of that, because it's a part, there is no additional protocol to run. There is no PIM. The traffic does not hit CPU at all. As a result, we can have thousands of multicast streams on our pizza boxes, and it's not a joke. We can have a small 1U box, and we can run up to 4,000 multicast streams on it. It is all being protected again by the same shortest path bridging redundancy. If you break a link, the recovery time will be same 10 to 100 milliseconds. So you can lose on 30 frame per second video, you can lose maybe 1 or 2 frames, right? So we use this technology extensively, and one of the main use cases for multicast Video surveillance, like I said, we have them running in casinos in Las Vegas. We have them running, or the systems are running in nuclear reactors for network monitoring, because you can build redundant network, you can build a ring, connect multicast cameras to it, and run routed multicast with millisecond recovery time. There is no other technology that can do it for you. That just doesn't exist. And we can do it inside those layer 3 VSNs as well, or VRFs. So here is a summary of all the technologies that we have available. Layer 2 services, we can transport VLANs. As a matter of fact, because VLANs, they only exist at the edge of the network, there is nothing to configure. They don't exist in the core. We can change VLAN ID. You can attach VLANs with different IDs at two sides of the network. We can do that. We can route inside the network natively. Right, we can provide layer 3 VRF or IP VPN services. We can combine all them together, and we can run multicast. So you can have all network operations from original Ethernet all the way up to your what would be MPLS IP VPNs on your local LAN network, all part of Ethernet itself, with a very few configuration commands, all natively run on the network. The whole stack of whatever is needed for the network, combined with edge-only provisioning and redundancy. Right. Right. Additional services. Switch clustering. I will be talking a little bit faster here. Looking at time here. So switch clustering. You probably know what the switch clustering is. When you can take two nodes, two core switches, combine them together to provide kind of LAC aggregation group to a server or to another switch. This technology again was invented by Nortel in about 2001. Everybody, all the other vendors, they have it now. But usually you would need those two nodes connected directly. With the fabric, they can be anywhere in the fabric. They can be in different buildings, and you can create a cluster out of them. I mean this is a very interesting, unique technology. Distributed virtual routing. This is again technology enabled by Fabric. The main use case for this one, if you have two data centers and you have a layer 2 connectivity between them, let's say you have servers on the left, and then your routers are on the right, and when you have multiple VLANs, traffic will have no choice, usually in normal network, to go across and back for routing, right? And it will be called tromboning or east-west traffic tromboning. So DVR is intended to get rid of all this, because each node can route between any VLAN right on the very first node, in this case, it's called DVR leaf infrastructure. Again, very powerful technology, very easy to deploy, is available in our hardware. Fabric attach is another technology that is enabled by Fabric. It's not so. There are a number of devices like IP phones, wireless access points, IP cameras, other switches, some virtual switches as well, that they do support this. It's right now it's a IEEE draft, and it was just recently updated. If you look at if you Google it, the idea for Fabric attach is for those devices to be able to connect to Fabric technology without using Fabric. So IP phone, for example, can signal which to the Fabric and request that ISIT. Remember, I mentioned ISIT, right? So, or a wireless access point. When you connect to the network, it will say, okay, I want to create a VLAN. I want to create connected to an ISIT based on something, based on a authentication backend. So the Fabric technology, again, I just glance over it because it needs a separate discussion, but we can extend it over to non-Fabric devices. Fabric AirSpan, quickly again, this is something we can take a traffic based on ACL and mirror it to an ISIT again, right, and transport across the network. This technology is used for packet for basically monitoring, centralized traffic recording or intrusion detection or packet capture. Again, only it's a part of Fabric services. This is UNI, or user to network interface. Since Fabric services, they do separate users from the infrastructure. As a result, what we can do, we can attach, we can send, we can change VLAN ID on two ends of the network. For example, we can take VLAN 10, and once it's connected to an ISIT, we can connect any other VLAN on the other end. But what is interesting, what we can also do with the as a side effect of it, we don't even need to create VLANs on a switch. So we can intercept VLAN queue tag and assign, based on queue tag, we can assign it to an ISIT, and on the way back as well. So we can make this technology allows us to create to enable this kind of automated services that we can transparently. So the whole idea is that you don't need to have a VLAN in order to put devices into VLAN. That's for flex units. Again, this may be a little bit outside of the scope for this discussion, but something else, transparent uni. This is something very interesting. You can in this case, I assign a port to an ISIT, and what Fabric is going to do, it will take all traffic, tagged, untagged, and send it across the Fabric. What you can do with this transparent uni interfaces, you can provide transparent services on your network for, let's say, for somebody else. You can transfer, you can take MPLS and transport it across your Ethernet network, and we have use cases like that, right? Or you can provide like a third party if you don't want to deal with their VLANs or MAC addresses. Just give them a transparent port, and you can have multiple transparent ports on the network. The private VLANs. Private VLANs is not new technology. It's allows you to have a switch with a single VLAN and full isolation between the ports. So the ports on VLAN cannot talk to each other, but they can talk to another port called promiscuous port or trunk port. It was used back in days by carriers. When a carrier would drop a box at location, say, okay, here's all your ports. You cannot talk to each other, but it's all common services going out to internet. What we can do with the Fabric, we can extend it over to other locations by Fabric as well. So you can have this private VLANs, not only they are available, you can extend it across the Fabric. Very powerful security technology related to security. Okay, applications. How much time we have? 10 minutes. Network design, and that's what. First of all, I hear all the time that we either our network is too small or it's too big for a Fabric or something else. In reality, Fabric, because it is Ethernet. Okay, it's a standard. It can be used anywhere. In the core, it can be used in a distribution. It can be, we can transfer it across WAN. It can be, we can run it across internet. We can encrypt it, right, with IPsec or MACsec. There is no really limitations where you can or cannot use Fabric. Use it anywhere. Again, it's more about think what you can do with it. Think about topology and the other services that are available there. Network size, well, you can enable it. You can run it with a single switch, for example, for multicast, routed multicast, and it can be tens of thousands of switches. There is no limitation on size of the Fabric. Any topology, ring, mesh, whatever you have. Recovery time, I mentioned that one. Plug and play, yes, you can. So how normally it's done, you allocate your number of ports on a switch for uplinks. Just all you do is say, this port is a SPBM port, nothing else. And then you can plug and play them. You can disconnect and plug them in any other port. It will work just fine. They're all identical. There is no reconfiguration ever. One protocol, you'll be amazed how simple it is. How it's not much in the network itself. I mean, it's not. If anything, it's way less complicated than your regular routed network. And for sure, it's a fully interoperable with any other protocols. You can extend VLANs, regular VLANs, to outside. And because it's just another ISIS, another routing protocol, we can do routing policies and send routes between ISIS, NSPF, BGP, and even multicast. We have a PIM gateway there. Okay. Yeah, and if you look at the traffic between the nodes, you cannot see user MACs. What you can do, you can transfer hundreds of thousands of MACs between the nodes. And let's say if you have a carrier, only allows you, usually you don't want to drop 200,000 MAC addresses, for example, if you're running a school board, and if you need a layer 2 connectivity for redundancy and for wireless network, you have 200, 300,000 MAC addresses. You don't want to dump it on a carrier network. With this one, with the SPBM, all they can see is 4 MAC addresses. Everything else will be tunneled. And sure, H-only provisioning. It can be done locally with a CLI, with the web GUI. It can be done through SNMP, through web interface. It can be done through APIs. It can be automated. It can be scripted. It can be done anything. Remember SDN? Well, we had it before it was, well, we knew it was SDN before SDN was a thing, right? We call it SDN with implicit automation, because this automation is a part of the network itself, part of the fabric, right? It's not, so other SDNs, they would have imply that you have a regular Ethernet network with all the protocols, and you have a SDN controller somewhere that is hiding stuff from you. Not in this case. So we can automate it any way we like. Okay, cybersecurity is one big thing, because traffic is going from point to point on the fabric network. The packets are never being disassembled. It is exactly the same packet from point A to point B. And network does not need IP addresses. What you can do, so if you look at your fabric network, all you will see is one end and the opposite end. You will never see anything ever. Doesn't matter how many nodes jumps you have in between. You won't see any of them. So we are running hackathons. I believe I don't know, maybe in COVID we didn't run them, and we offer $10,000 for hackers to break in our network. So far, nobody was able to hack into it. So hybrid segmentation, or another concept we call network elasticity. You can, because of this H-only provisioning and embedded automation, you can script it and you can create services on fly, right? Based on automation, based on your backend, you can what you can do, you can again fly. You don't have to actually pre-configure anything, and I will probably go to some of it. With the backend, you can create ISETs and you can create VLANs on fly. With the fabric attached, they can request those services. The long story short here, you can make network fully automated, flexible, and it will, if you add a device to network, it can request a service, it will create a VLAN, and if you disconnect it, the whole configuration will be pruned and as it never existed. You can create those with radius. You can create private VLANs. You can create regular VLANs, and the network-wide VRFs. That's another powerful technology. People, once they can kind of get what it does for them, they want it. Okay, customer success stories. Well, they call Extreme Fabric is the best kept secret, which we don't want to be kept as a secret, to be honest. We have more than 10,000 deployments in all verticals: transportation, manufacturing, education, and I can, like some very big networks running our fabric, like anywhere from bullet train in Japan, and some. Anyway, so manufacturing, education, municipalities, healthcare. There is not a single vertical where I say don't use it. I mean, it is applicable, can be used anywhere. Okay, I have so here I have one of the latest. Actually, this is a real network for a small municipality here in Ontario, and they have a number of sites, like locations, physical locations across the city, right? And all connected by dark fiber. And it is actually the actual. We have they're working on some additional deployments right now. So the requirements not only to have multiple rings, right? They wanted layer 3 routed services at each location. They wanted some VLANs to be layer 2 for between data centers, for example, and between some other locations, and also needed multicast for video on top of that. That's what we could do. This is a completely no-brainer. I mean, like it's a dream, right, for network designer to build this network based on shortest path bridging or fabric. All these red ports are NNIs. They can be configured. They're all identical. You don't have. There is no configuration on them at all. You can add. You could probably see here a couple of clusters, right, for SMLT. So you can have servers connected to top of rack, and so on and so forth. Bottom line is, this network is almost impossible to do with regular network. Yes, they had it running before with OSPF, spanning tree. One part was always disabled manually because it would never come up properly, and PIM, which never worked. So in this network, I can literally, for example, if they wanted to reconfigure the switch, I can disconnect the port here, connect it right there, no reconfiguration, and it will just work. And then I can move it back with no issues. Just to give an example how it works. Final thoughts. Well, it's IEEE. It's Ethernet itself. 10 years. So we have, even in Canada, we have fabric networks running before it was a standard, since about 2009, I think. Suitable for everything. So we have which hardware supports it. We have extreme. If you look at our website, extreme universal switches, VSP series, all of it supported. There is probably 50 different devices that do support fabric. So here's some final thought again. This was done not by us, by some researchers, and you can read the improvements. And apparently, there's testament that yes, it does really work, and the customer do really see improvement in all the aspects of the network. Right. Additional resources. Well, there is a tons of things that are available on our website. In addition to that, we have training free of charge. You can sign up for fabric training as well, or you can just reach out to your local sales engineer or your local extreme representative, and we will help you. All right, be pretty much on time here. Scott, Greg, did we have any questions?
There were no questions, so you must have been quite clear. And
or maybe I was on mute all this time. I don't know. I don't know.
No, you were not.
All right. Well, thanks everybody. I hope it was useful. If you have any questions.
Wait a second.
All right.
There's a question that popped up. You should see it, Andrew, or?
Yeah. Is there any limitations for non-SPBM? Absolutely not. We can connect our network to any switch, to any network. In fact, you can have pockets of a fabric network connected through regular infrastructure, and the opposite, you can have a fabric core and you have, let's say, edge switches from any other vendor, or there is no limitations whatsoever. And if you need routing, we can absolutely do routing. Yes. Thanks, Sean. All right. If you have any questions, please feel free to reach out. This will be, I believe, it will be recorded and posted on the web. I do encourage. This is not. There was nothing proprietary in this presentation. Please share it with all your friends, and hopefully we will work together. Thanks. I will stop now.
Thank you, Andrew.
You're welcome. Bye-bye.